Hello, welcome everyone to today's physics class. Our topic, we're going to look at work, energy, and power. We're going to start with our definitions. My name is Mr. Peter, and this is physics. So work, energy, and power. So I'll go straight into it. What is work? The work done on a system by a constant force is the product of the component of the force in the direction of motion and the distance to which the force acts. I repeat, the work done on a system by a constant force is the product of the component of the force in the direction of motion. You can see I have put in quotes the component of the force in the direction of motion. Quite important to get that the force has a component, and that the force we're interested in is the component of the force that's in the direction of motion, and the distance to which the force acts is a product, some scalar product. We're multiplying the force, and the distance. Work done is basically the force, magnitude of the force, and the distance. The magnitude of displacement just with distance, cos theta, where theta is the angle between the force and the displacement. We can imagine a lawnmower. This is my funny diagram of a lawnmower. The lawnmower is being pushed at an angle to the horizontal. So theta is our angle. We see the lawnmower moves in the x direction. We're interested in the horizontal component of our force because the force is acting at an angle. Look at the force F acting at this angle to the horizontal theta. We're interested in the distance and the force that is in line with that distance. Basically, so it is F cos theta. All right, and of course, if the force is parallel or in line with the distance the object moves, then theta is 0 and cos 0 is 1. So it just becomes cos theta disappears or becomes 1. Work done is equals to force times distance, where theta is 0. That means there's no angle between the distance the object moves and the force that causes that movement. All right, SI unit is joule. The SI unit of work done is joule, and is equals to 1 Newton meter, because Newton is the SI unit for force and meter is the SI unit for distance. And it's also equals to 1 kilogram meter squared per 1 kilogram meter squared per second squared. Basically, we're talking about, of course, notice force times distance. All right. And note, it's a scalar quantity, not a vector. It's a scalar product, not a vector product. That is why work done is a scalar quantity. Yes, work done is a scalar quantity. Why is work done? Work done is scalar because it does not matter which way you push an object. The work you do to overcome the friction of it against the floor is the same. So whether you push an object to the right and then you push it to the left, work is still done. So the direction doesn't matter. So work is a scalar quantity. It's not a vector quantity. Other definition for work is the transfer of energy by force acting on an object as it is displaced. So work involves transfer of energy. So the relationship between work and energy. So work is the transfer of energy to an object as it is in the direction in which it is displaced. The work done is positive if the force and displacement have the same direction, and negative if they have opposite direction. In the same direction, cos theta becomes cos 0, which is 1, like I said. And if they are opposite, that's if the force and the direction of displacement are opposite, cos theta is 180 or theta is 180 degrees, and so your work done is -1. Take note, this is your standard formula for work done. Is the force times the distance times cos theta, where theta is the angle between the force F and the displacement. That said, let's look at an example. Example 1, a boy drags a bag of rice along a smooth horizontal floor with a force of 2.5 newtons applied at an angle 30 degrees to the floor. The work done after a distance of 3 meters is, I repeat, a boy drags a bag of rice along a smooth horizontal floor with a force of 2.5 newtons applied at an angle 30 degrees to the floor. The work done after a distance of 3 meters is asked to find the work done. Solution. So let's get the force. The values we are given. We are given the force F as 2.5 newtons. The angle at which the force is applied is not straight. It's not a straight application. It's being dragged at an angle to the horizontal, to the floor. 30 degrees is that angle. Then the distance the object moves. Distance moved by bag, S symbolize distance as S or D, depending on the case, what the case may be. In our formula, we are using D. Some other textbooks use S to symbolize distance or displacement. So it moves a distance of 3 meters. It's given from the question. These are the values we're given. Now the formula for work done is W is equal to F cos theta times S. Now cos theta comes in because we have an angle. Theta has a value. The force is applied at an angle. So applied at an angle. Take note, applied at an angle. Theta is 30 degrees. Slot that in. Our force is 2.5 from the question. Cos 30 degrees times 3. So you can look at the diagram here. This is our bag of rice. And this is the force. The force that the boy applies is at an angle. It's not straight horizontal or straight vertically. So it's at an angle of 30 degrees to the floor. The component of the force, remember, worked on the component of the force we're interested in is this component because it's the one that is applicable to the bag. It's the one that drags the bag along the distance, the horizontal distance of 3 meters. Remember our formula for work done is the product, that's the multiplication of the component of the force in the direction of motion. The bag doesn't go up, it goes horizontally. We're interested in the horizontal component of our 2.5 Newton force. The horizontal component, remember, from our splitting resultants is F cos theta in this case, and the vertical component is F sin theta. But we're interested in the horizontal component because that's the direction in which the object moves a distance of 3 meters. With that said, we put in the values, point those values into the calculator, and you get that the work done is 6.49 joules. I hope that was clear. Thank you.